Hello, friends. Today we learn about Dijkstra algorithm. So Dijkstra. It's a little bit tricky. Dijkstras algorithm. So it is a very popular algorithm. It is used to find the shortest path from a source node to all other nodes. But you have to keep in mind that the graph has to be weighted graph and the weights have to be non-negative. Okay, so let's see an example. So if I have a node A here, B, C, D, and E. From A to B, let's say the weight is 10, B to C 2, sorry, A to C 2, 1, and B to D, the weight is 7, and D to C or C to D, weight is 2, and D to E, 5, and then the last one is 2, B to E. So what is does? Okay, let's make a table here. The table has to be node, weight, and previous node. My bad. Little bit better. Okay, so how many nodes we have? So we have A, B, C, D, and E, 5 nodes. So at first we assign all the nodes except for the source node infinity. That means the biggest possible value. So let's do it. Let's say A is our source node. So you see source, and for a source we assign the weight 0. For here 0, and all other nodes, let's start with infinity. So now from A we start here, and then we see we take the neighboring nodes, or we take the children. So who are the children? B and C here. So let's go with the, by order of alphabet. So let's do B first. So from A to B, what is the weight? It's 10. Over here, the current weight we assigned is infinity. So 10 is less than infinity, so we update. So this is called path release. So we update the weight. Let's do it and update it to 10. My bad. 10. And then what is the previous node? That means what did it come from? From A. The previous node was A. So we write it here, A. And then we go to C. So A to C, the weight is 2. Okay. it's not 2, it's 2 plus, technically it's 2 plus 0, the weight of A, and 10 plus 0. So 10 plus 0 is 10, 2 plus 0 is 2. So 2 is less than, we see the current weight is infinity, so 2 is less than infinity. That means we'll replace it by 2. And the previous node was A. So now A is visited. So we do visited. Okay. Then we look at here, all the unvisited nodes, and we go by the minimum weight. So the minimum weight is 2. So 2 in which node? C. So you go to C. So when you go to C, now is the current node is C. So from C, A is already visited, so you cannot go to A. So we can go to B and D. So from C, what is the weight of C? Is 2 now. 2. So it's 1 plus 2. Wherever we go from C, we have to add the weight of C. So 2. Okay. So if we go to B, then the weight is 2 plus 1 is 3. So what is the weight of B here? The weight is 10. So 3 is less than 10. So we replace 10 by 3. And what is the previous node? C. Again, we, we update the previous node. From here, what we can see, and then we go to D. D is left, I'm sorry. So D is left. So if we go to C, the weight is gonna be 2 plus 2 equals 4. So what is the weight of D here? It's infinity. So 4 is less than infinity. That means we have to replace infinity by 4. And what is the previous node? C. Now all the edges are visited, all the nodes, neighboring nodes are visited. That means C is visited completely. Okay, C is visited. Now, what are the unvisited nodes? B, D, E. Okay, from B, D, E, which one has the minimum value, the lowest value? 3, 4, infinity. That means 3. Okay, so you go to node B. So if we go to node B, if we see it has like 4 neighboring nodes, but 2 of them, A and C, are already visited. So we don't go A and C, we go to B and we go to D and E. So B has a weight of 3. So if we go to D, so the weight of B is 3 now. The current node is B, and then 7 plus 3, and then over here 2 plus 3. We have to add the weight of B. Okay. So if we go to D, then the weight is 7 plus 3 is 10. But what is the current weight of D? Is 4. So we don't need to replace it since it is lower than 10. Then we go to E. So what is the weight? Is going to be 2 plus 3 equals 5. What is the current weight? Is infinity. So we replace infinity by 5. And then the previous node is B. So B is visited now. Okay. Now we see B is visited, A is visited, C is visited. The unvisited nodes are D and E. So the lowest is 4, the weights are 4 and 5. So we go to node D that has weight 4, lesser weight than E. So for node D, it has three neighboring nodes. But B and C are already visited, so we go to E. So what is the weight of D is 4. So if we go to E, so 5 is already, it has the weight of 5, and then 4 is 9. So for E, if we go to E, then what is the weight? We see is 5. So 5 is already less than 9, so we don't need to replace 5. Okay, so D is visited here. So if we go to E now, so E is left, since E is left. So if we go to E, we see all the other nodes are visited. They have updated weights. So we don't have anything to update. Okay, now you see all, if we go to A, if we go to C, the updated D, the updated weight is 4. If we go to C from A, the weight is 2. So let's see how it works. So from here, let's draw the graph again. So A, B, C, D, E. Okay, so A, so the weights are, for example, 10, 2, 1, 2, 7, 2, 5. Okay, so this is our source here. For example, if you want to go to D, there are several routes. I can go from A to D. I can use this route, A to D. I can use this route. I can use this route. I can use this route. But which one I'll take? The lowest weight. So that takes the lowest weight. So from A to D, the lowest weight is 4, it says here. So how it works? So let's do over here. So if I take this route, so it's 10 plus 7, the weights are 17. It's not the lowest. So let's forget about this. Okay, 10, 17. If I take this route, this 2 plus 2 plus 4. If I take this route, it's gonna be 10 plus 1 plus 2, 13. If I take this route, it's 2 plus 1 plus 7, 10. So which one I'll take out of all 4? I'll take this one. That says this is the shortest path that takes the smallest amount of weight. I hope you understood, and thank you very much. See you in the next video.